Hello, everyone. Now let's go over worksheet 2 solutions together. Question number 1, we want to draw a bar chart by hand for the following data. The data shown consists of average number of hours that a commuter spends in traffic, congestion per year in each city. So we have the city and different categories. For this specific question, just different cities, and then the hours, which is the data, right? So we have 52, 64, 61, 74, 82. A bar chart is for qualitative variable or categorical, right? So we can just kind of label all the different frequencies, and then write down the different bars. So just different categories, right? Atlanta, Boston, Chicago, New York City, Washington, D.C. And then the height represent the frequencies or the hours here. So the first one is 52, so a little over 50, and then 64, 61, 74, and then 82. So that's how we draw it by hand. Again, bar chart is for qualitative variable. And number 2, we want to construct a stem and leaf plot for the following data set. An insurance company researcher conducted a survey on the number of car thefts in a large city for a period of 30 days last summer. The raw data are shown below. So we have 1, 2, 3, 4, 5, 6 rows, and then 5 columns. So we have a total of 30 numbers here. And that matches with what the 30 days, right? The 30 days. Now let's first just separate the stem and leaf, and then naturally we can do the tens and then the unit digit, right? So we have 50 something, 60 something, and 70 something. So the draft version of the stem leaf plot is right here. So we have stem. We can go column wise, right? So 50 something, 52, so we're at 2, and then 8, 75, 79, so 75, 79, and then 62, 77, so on and so forth. Then we have this draft version done, right? And to make the final version of the stem and leaf plot, we there's one requirement, right? We have to put all the leaf numbers in proper order. However, for this one, we only have 3 levels for the stem, which is not very good to show the distribution of the data. So then we can actually separate each level with the low and high, right? So 0 to 4, 5 to 9, 50s low and 50s level high, 60s low, 60s high, 70 low, 70 high. Then we have this stem set up, and then just come from the draft version, the leaf numbers. We can reorder it, and then 0 to 4 put in the low, and 5 to 9 put the high, and then also in proper order. So this is the final version of the stem and leaf plot. And then we can say the distribution for this data set is pretty symmetric. That's question number 2. And number 3, want to use the cut point grouping method to construct a frequency distribution. So including the frequency, relative frequency, cumulative frequency, and then cumulative relative frequency. So the data set is for 11 volunteers from the previous stat course, sharing their residence to SHSU distance. So we have 0.5, 0.5, 0.6, and then the last number is 53. So step one, we want to sort the data, put everything in increasing order. So for this one, it's given that way. So for step one, we just check that. And step two, we want to calculate the width. So the width equals range divided by the number of classes preferred. So for this one, it's not only 11 number, right? Is not a lot. So we can go something low, right? So 4 or 5 classes. I think from the lecture notes, we have an example of 4. So this one we try propose 5 classes. So the range is the largest number minus the smallest number. So 53 minus 0.5 and divided by the proposed number of classes. So propose 5 classes. So divided by 5. And then the calculation is actually 10.5. So 10.5. To make the calculation easier, we can round this up to 11 or round down to 10. So 10 is compared to 11 easier, right? If you want to calculate the classes, the upper limit, lower limit. So we're gonna choose just round down a little bit to 10. So then step 3, we can write down class, frequency, relative frequency, cumulative frequency, cumulative relative frequency, right? So we start with the frequency column, and then the rest is just going to be based on the frequency column. So for class, we start with the smallest number from the data set, so which is 0.5, right? So the little bar means 2, smaller than, right? The notation is a little bar and then the smaller than sign. That means 2 smaller than a number. So the lower limit start from the smallest number in the data set, 0.5, and then plus the width, right? We decide to choose 10 to be the width. So 0.5 plus 10, that's 10.5. So that's the lower limit and then upper limit for the first class. 0.5 to anything smaller than 10.5. So up to 10.5, but not include 10.5 in this class. That's because we want to include 10.5 for the next one. Otherwise, there's overlap, right? For classes, we don't want any overlap. So 0.5 to smaller than 10.5, and then the next level we start with 10.5 to smaller than 10.5 plus 10, so that's 20.5, and then so on and so forth until for some class, right, the upper limit covers every number there. So if we go only to 50.5, there's still a number 53 nowhere to put, so we have to go one more, 50.5 to smaller than 60.5. Then 53 is smaller than this upper limit, and then we can call it, that's all classes. So let's count 1, 2, 3, 4, 5, 6, right? We propose to have 5 classes, but we end up with 6 because of the rounding, and then that's okay because we want to just see the overall distribution, overall frequency. So one class more or one class less doesn't influence the overall distribution or the shape of the data, so we should be good. And then just put the tally right down, and you don't have to include the tally, just the frequency. So 0.5 to 10.5, 1, 2, 3, 4, 5, right? So 5 numbers. 10.5 to 20.5, nothing, so put 0. 20.5 to 30.5, we have 3 numbers, right? And then 30.5 to 40.5, 1, 40.5 to 50.5, 1, and then 1 for 50.5 to 60.5. So the frequency or the count are 5, 0, 3, 1, 1, 1. And then altogether we should get 11. So 5 plus 3 plus 1 plus 1, that's 11, no problem. And then relative frequency is just the frequency divided by the total number, right? So 5 over 11, 0 over 11, 3 over 11, so on and so forth. And then cumulative frequency is up to this level, what's the count? So for the first class, 5. Up to the first 2 classes, 5, right? 5 plus 0. Up to first 3 classes, so we have 5, 0, 3. So altogether, that's 5 plus 0 plus 3, so that we got an 8. And then up to the 4, 9, up to the 5th, 10, up up to the 6th class, 11. Note that for cumulative frequency, the last number gonna be the total count, because that's everything, right? Everything is the total, so 11. And then cumulative relative frequency is just the cumulative frequency divided by the total. So 5 over 11, 5 over 11, 8 over 11, up to 11 over 11. And again, for cumulative relative frequency, the last number here is 100%, because that's everything, right? Okay, that's question number 3. And then question number 4, we want to draw a histogram by hand for the distance data, right? A histogram should be based on the frequency distribution we have here. So we have 5, 0, 3, 1, 1, 1, and then the cut points are the lower limit of the first class and then all the upper limits. So 0.5, 10.5, 20.5, 30.5, 40.5, 50.5, and 60.5. So for the axis, we put all the cut points down. Of course, the width should be the same because width is 10. So 0.5, 10.5, 20.5, 30.5, 40.5, 50.5, and 60.5. So we have what? 1, 2, 3, 4, 5, 6, 7 cut points. So that makes we have 7 minus 1, 6 bars. And then 5 for the first bar, right? 5, 0, 3, 1, 1, 1. Perfectly match the frequency, and that's a histogram. Okay, number 5, want to construct a stem and leaf plot for the distance data. And then we have a hint here, right? Proper rounding is necessary for the distance data for this one, right? So the data we have are listed below 0.5, 0.5, 0.6 up to 53, right? So if we don't do any rounding here and just separate the stem leaf by using the decimal point, then we're gonna end up with 0.5, 0.5, 0.6, 1.3. The second level is 1 point something. And then we have 2 point something, 3 point something, 4 point something, up to 24 point something, all empty. And then we have a level 25, and then a gap, and then 27, gap 29.4, and then 37.0, so big gaps. And the stem or the row is going to be very long and with a lot of empties in between. For that stem leaf plot, we cannot see the distribution, so that means it's not a good one. So then we have to do some proper rounding here. So 0.5, we just round to 1, 0.5 to 1, 0.6 to 1, 1.3, just the regular way how we round it to integer, right? 1.3 should be 1, 1.5 then it's 2, 25, 27, 29, 37, 42, 53. So then the stem gonna be the 10th unit, right? So 0, 1, 1, 1, 2. So because nothing for the 10th is just unit digit, right? Number here. And then do we have 10, 12, 13, something for the 10th level? Nothing, so it's empty. For 20 something we do have, right? 25, 27, 29, so we have 5, 7, 9, 30 something, we have 7, 42, and 53. Then we can clearly see the distribution of this data, right? So this is how we make a stem leaf plot for data with really large range, and the distribution is right skewed with a lot of number less to the left side, right? Okay, that's number 5. Okay, that's everything for worksheet 2 solutions. Thanks for watching.